Hello. In this video, we are learning about applications of vectors. This is part 2 of a 2-part series of applying vectors in real situations. So if you've not watched part 1, you need to pause this video and go back and watch part 1 of applications of vectors. So we're going to dive right into an example. 2 tractors are pulling on a tree stump. One truck is pulling with a force of 200 pounds at an angle of 55 degrees, and the other is pulling with a force of 300 pounds at an angle of negative 40 degrees. What is the resultant force and the direction? So this is a formula that we used in the previous video. The magnitude times the cosine of the angle of I plus the magnitude of the vector times sine of the angle of the vector j. So let's draw out this picture. Okay, so the first tractor is pulling on the tree stump. Let's say the tree stump is right here at the origin. It's pulling on the tree stump. That's a really big angle of 50. Well, I guess that's almost. It could have been even more. Angle of 55 degrees. And the force is 200 pounds. So let's say, let's call this angle U. This vector U. And we're going to say that the magnitude is 200 pounds. Okay. Now the other tractor is moving in, it's pulling at an angle of negative 40. So we know it's below the x-axis. It's pulling down. So this angle here is negative 40 degrees. Let's call this vector V, and the magnitude of this vector is 300 pounds. Okay, so we need to find our vector, our component form of the vector for vector U and for vector V. We're going to use this same formula that we see on our screen for both. So U is going to equal the magnitude of U, okay? We're just going to change out some of these variables, times the cosine of your angle, and then the magnitude of U again, times the sine of the angle, and that's going to be the vertical component, okay? So only thing we did is we changed the variables because we are naming this vector U. So the magnitude of U is 200. The angle of U is 55. Once again, the magnitude of U is 200. The angle is 55. So I'm going to plug both of these into my calculator to get an answer. Now, because I'm going to continue to rewrite these, I'm only going to round them to the nearest tenth. So 200 times the cosine of 55 is 114.7. And then 200 times the sine of 55 is 163.8. Okay, so now we're going to do the same exact thing for V. So V will look like this exact formula right here, so I'm not going to rewrite it. The magnitude of V is 300, and the angle of V is negative 40. The magnitude of V is 300, and the angle of V is negative 40. So plugging both of these into our calculator, 300 times cosine of negative 40 is 229.8. And 300 times sine of negative 40 is negative 192.8. Okay, now because it was negative 192, I changed this addition to subtraction. All right, so I'm going to, on the next slide, you will see both of these vectors typed out because I want us to have a clear, clean workspace. Same problem, here are 2 vectors. Okay, what we need to do is, it is asking for, remember, it's asking for the resultant force and the direction, okay? Our force is our magnitude of the vectors. So these 2 vectors are acting together, therefore I must combine them. And to combine them, I need to add them, okay? So I'm going to add corresponding parts. 114.7 plus 229.8. That is 344.5. And then I'm going to add 163.8 minus 192.8. Or I can look at that as 163.8 plus a negative 192.8. Whichever way you want to look at it, and that's going to give me a negative 29. But I'm not finished here. Remember, resultant force is the magnitude. So I need to find the magnitude of U plus V. So I'm going to square my X component, and I'm going to square my Y component, and those add together. Now, we always use parentheses, but remember this one is even the most important use parentheses because we are squaring a negative number. So I can put this in my calculator, 344.5 squared plus a negative 29 squared. Oh, that's a really big number. Okay, we're actually going to leave it written just like this, and that is perfectly fine because the number is actually 119,521 and 25 hundredths. So we're going to just leave it as it is because there's just no need. All right, and now we need to find the direction, okay? Now we need to find the direction. So to do that, remember the beginning of the unit, we found out that tangent theta, all right, let me spell tangent correctly. To find the direction or to find the angle of a single vector, okay, because now we have the single vector u plus v, we could rename this w if we wanted to. We have the vector u plus v, and to find the direction of that, that's tangent theta equals our y divided by our x. So tangent theta equals our y, which is negative 29, divided by our x, which is 344.5. And using our inverse trig rules, I need to do tangent inverse of negative 29 all over 34.5. And I'm going to use this by typing this into my calculator. So negative 29 divided by 344.5, and that's going to give me a negative 4.8 degrees. So our resultant force is the square root of 344.5 squared plus negative 29 squared, and our direction is a negative 4.8 degrees. Okay, let's look at another problem. We're going to talk about work in this problem. Work is the transfer of energy from one object to another. Y'all, like, we are really diving into physics. Vectors are in physics all over the place, and you're like, we're in math class. Well, if you ever take a physics class, again, this will help you. So our work is force times S. What is S? S is direction. The reason why there's not a D here is because D represents distance most of the time. So we're going to say F times S. So work equals F. Okay, so now it's time to do an example for work. A wagon is pulled by exerting a force of 25 pounds on a handle that makes a 35-degree angle with the horizontal. Find the work being done in pulling the wagon 50 feet. Okay, and in the last slide, I think that I told y'all S was direction. S is the vector of the distance. I don't really know why it's what I was saying or why it's represented with S. I was just talking crazy, I guess. I don't know. So let's draw us a picture. We know that there is a wagon, and it's being pulled. It's being pulled a total of 50 feet total. It's being pulled with a force of 25 pounds, and the angle is 35 degrees. Okay, so the distance that it's being pulled, if S is distance, it's being pulled 50 feet. So 50 across the horizontal. Now, whenever they're pulling this wagon, it's remaining on the ground. So that's still the vertical is still going to be 0. So that is our S there. Our S is our distance, and it's just how far is whatever we're pulling or pushing, how far is it going? Okay, so now we need to figure out our force vector. And to use that, we're going to use the formula that we were using earlier in the example. So our magnitude is 25. Our angle is 35. And our magnitude is 25 and our angle is 35. Let's use sine. Let's follow the formula correctly. Okay, so once again, I need to plug in 25 cosine of 35 with my calculator in degree mode, and I'm going to get 20.48. 20.48i. And then I have 25 times sine of 35, and that is 14.34 J. Now, if I'm going to find the dot product, work equals F dot S, let's go ahead and write this in the form that we're used to seeing so that it will be easier for us to find the dot product. Okay, so work is F dot S. So we're multiplying our X components together, 20.48 times 50, which is 1024, plus our Y components together, 0 times 14.34, and 0 times anything is 0. So our work is 1024. So that's how to find work in a situation like this. Work is force dot our vector for our force dot our directional vector. So that concludes this video and our application of vector series.